So today I learned this game cheats, and I'll go over how I found that to be the case. It was quite the journey to figuring it out. I started my project off in Python, which I thought it was a performance issue, because of course Python is an interpreted programming language, so it's a little bit slower. So I figured, hey, I'll do it in C++, which should be a lot faster, and I should be able to send my inputs on time. So, but however, the game actually cheats, and I'll kind of, I spent a lot of time figuring that out the painful way. Of course, the game I'm talking about today is Pokemon Yellow. Came out in 1998. Pretty surprised that it has an RNG element in like a kid's game. Seems pretty unnecessary, but I will kind of go over I'll go over a top view of my code. So I did use C++, and I used the OpenCV for pattern matching. And basically, let's say this is the window, and these are our bars. Let me draw. Here we go. So here's my search region for bar 1. So it is kind of convenient that whenever you start the slot machine initially, all the 7s are lined up on the screen. So I'm basically searching here. Once this roller gets rolling, this region is captured and it's saved as a template. And then the code is constantly checking the screen if the region is matching our captured templates. So of course that's bar 1. This here is bar 2. And then this here would be bar 3. So C++, you gotta kind of go the extra mile if you want to do something as simple as like send a key press or to simulate a key press. I basically took a lot of this code from like Stack Overflow, so it's kind of weird. Yeah, there's a lot here. I'm not going to really go over that because this is just like, it's kind of like Windows specific. But all right, so this here is a capture region function. It'll take in a rectangle, which is screen coordinates, and then the handle of our window, which is RetroArch in this instance. And then, we grab all that, and again, in C++, you got to do a lot of this like tedious tracking of your bitmaps and stuff. And for the longest time, I thought my issue was a performance issue. So I initially was doing these calculations in color, which is it's a matrix. It's a 3-dimensional matrix, and then it's 3 dimensions because you have your red, blue, green color channels. Now in gray, it's a 1-dimensional array. You're only concerned with grayscale. And of course, in each pixel value goes from 0 to 255. That's just how images are stored in general. So then this here's our check template function. This lets us control how precise the match needs to be. So, and then oh yeah, this here is like kind of like a helper region. I use this to do some calculations because I had to manually, I manually found these regions, and then I set them as a percentage of the window, so that each time you played the game, because I wanted to share this code so that others could use it. However, since the game cheats, yeah, it's not really a useful project anymore, but learned quite a bit. But anyway, yeah, make it all relative to the window, so that way if they have it, times 6, we can just take a look. You could, there's different scales you can of course run the game in. So I wanted to make sure that each time it's ran, it'll hook into this window. It'll find the specific regions of search and make sure that everything stays consistent, regardless of the window scale. And then that's these values. And then, so with the logic, it's set this to false. This is what I'm using as a flag for when it matches. And then set it to false first, and then while this is false, run the check template. It's searching that middle region. This is our in memory, like kind of like cached of what that image looks like that we're checking. This is the precision. All these values are pretty much fine. So I could probably do 0.05 on all of them, but there's a lot of little things that you can tweak. So one of the biggest things that I tried changing is after the template has been matched, it hits this if statement, and then this sleep is pretty important. So if I tried forcing the 7 in the bottom, like this 7, forcing this in the bottom position. So how we can do that is, as soon as we get a match, we can sleep the program just a little bit so that it delays the simulate key press, and that'll kind of force that 7 into the bottom position. And then for debugging purposes, I wrote the images to disk. And actually, I'll just pull those up real quick. All right, and here's those images. So our auto crop region is, when the program first starts, it captures the middle of the bars. So these are the templates that are being checked. And then whenever it matches, I was curious what the program was seeing when it was matching, because I was like very confused as to why bar 3 was never working. I thought maybe it was just too slow. However, as you can see here, it matches. This bar 3, and that's a perfect match, meaning the game cheats. With a little bit of further investigating, I will show you what else I found. So then I further looked into it, and then people have disassembled the ROM of the game. So we can look at the assembly code for it. Under scripts, we go to, okay, so under scripts, there's the game corner. And this is a very, very interesting, and well, There we go. It's rigged. Basically, basically the game sets a lucky slot machine. So, and here it calls random. So, the slot machine, like, you have to use the lucky slot machine, basically. If I would have known this ahead of time, like, that would have saved me so much headache. but, but there it is.